Astronomers have uncovered a possibility that challenges everything we thought we knew about the deaths of massive stars. Some of these giants may not end their lives with a brilliant explosion. Instead, they may simply vanish, collapsing silently into darkness. And that raises a fascinating question. What if the next star to disappear is Betelgeuse? For generations, scientists have expected this enormous red supergiant to eventually create one of the most spectacular events in the universe, a supernova visible from Earth. But what if that never happens? What if, instead of exploding in a massive burst of light, Betelgeuse quietly collapses and leaves behind a black hole? Would Earth face any danger? Would the night sky change forever? Or would humanity witness one of the most important discoveries in the history of astronomy? In this video, we'll explore what scientists believe could happen if Betelgeuse became a black hole, separating what we know from what remains unknown, and imagining what humanity might experience if one of the most famous stars in our skies suddenly disappeared. Let's begin. For most of modern astronomy, the death of a massive star seemed predictable. After millions of years of burning through its nuclear fuel, a giant star reaches a point where it can no longer fight against its own gravity. The core collapses, triggering a tremendous explosion known as a supernova. For a short time, that explosion can become brighter than billions of normal stars combined. The blast tears the outer layers of the star into space, while the remaining core transforms into one of the universe's strangest objects, either a neutron star or a black hole. This was the ending scientists expected for almost every extremely massive star. But recent observations have suggested something much more mysterious may also happen. Some massive stars may fail to produce the spectacular explosion astronomers have always predicted. Instead, their cores may collapse directly, disappearing from sight and creating black holes without a visible supernova. A star could spend millions of years shining brightly, only to suddenly fade away and leave behind almost no obvious evidence of its final moments. If this strange type of stellar death is real, it would completely change our understanding of how the universe creates black holes. And that brings us to one of the most famous stars humanity has ever observed, Betelgeuse. Located roughly hundreds of light-years away in the constellation Orion, Betelgeuse is a massive red supergiant approaching the final stage of its life. It is so enormous that if it replaced our Sun, its outer layers would extend far beyond the orbit of Mars. But the fate of Betelgeuse is not decided by what we see on its surface. The true battle is happening deep inside its core. For millions of years, Betelgeuse has survived because two powerful forces have remained in balance. Gravity has constantly tried to crush the entire star inward, while nuclear fusion inside the core has pushed outward, creating enough pressure to hold the star together. This balance has allowed the star to continue shining. But eventually, that balance must end. When the fuel inside the core runs out, fusion begins to weaken, gravity takes over, and the core begins collapsing at incredible speeds. In just moments, matter is compressed under unimaginable pressure. At that point, everything depends on one final question. Can the collapsing core create enough energy to launch a supernova? Or will gravity become too powerful, causing the star to collapse completely into a black hole? If Betelgeuse explodes, humanity could witness one of the greatest astronomical events ever recorded. But if the collapse happens quietly, the discovery would be even more extraordinary. Humanity would not simply be watching the death of a famous star. We would be witnessing the birth of a black hole in real time. So what would people on Earth actually see? Imagine looking toward Orion on a clear night. For thousands of years, one bright red star has marked the constellation. It has been a familiar landmark for civilizations across history. Then one night, something changes. The star begins fading. There is no enormous flash visible from Earth. No destructive wave races toward our planet. No sudden cosmic disaster occurs. The world continues normally, but astronomers would immediately know something incredible had happened. Specialized observatories would detect unusual signals coming from the direction of Betelgeuse. Telescopes across Earth and in space would turn toward Orion, searching for answers. Scientists would expect a supernova. Instead, they would find silence, a missing star, a mystery, and that mystery would become one of the greatest scientific investigations humanity has ever attempted. Every available telescope would search for clues. Researchers would study the final moments of the star's collapse and analyze every signal that escaped before the black hole formed. They would ask questions that have challenged astronomers for decades. How do massive stars create black holes? Can a star disappear without a supernova? What happens during the final seconds before gravity wins? A quiet collapse of Betelgeuse would not be a threat to Earth. It would be a once-in-history scientific opportunity. Instead of discovering a black hole long after it formed, humanity could watch one being created. The greatest surprise would not be that Betelgeuse became a black hole. The greatest surprise would be how peaceful the event appeared. The universe might not announce the death of one of its brightest stars with a brilliant explosion. It might simply allow the light to fade away, leaving behind one of the most mysterious objects in existence. A black hole born from the disappearance of a star that humanity had watched for thousands of years.